anything you want. Yes.
So
Trace.
that the odd
Multiplicity. Yes.
multiplicities,
Correct.
like the 3, that's like to the third power, if that's like the radical of 3.
No.
Just the
No.
power.
So for example, very good question. F of x equals x cubed. We graphed this function when we talked about symmetry.
Right.
And remember, you may remember the graph, I hope. So let me graph it again. So it's not like this.
Right.
It's like this. Because x cubed equals 0 has 3 solutions and they're all x equals 0. Otherwise, he would have crossed, if the multiplicity is 1, it looks like this. But since the multiplicity is 3, it crosses, but very slowly.
Okay.
It doesn't mean that this is made out of 3 points. It's still 1. But since the solution appears 3 times, that's what happens.
Okay.
And the same thing with even multiplicity. So for example, f of x equals x squared, we know this graph. We graphed it so many times. X squared equals 0 has 2 solutions, x equals 0. That's why it's a term. Is that clear?
Yeah.
We're going to see it better in problems. We didn't get the chance to graph any. Yes, next question, please. Daniel, you had something?
Yeah, it was in regards to homework. There was a word problem where looks like fencing was supposed to be used around 3 sides of the backyard.
Yes, do you remember what it is? Can you?
Yes.
Very good. It's a very good problem. Let's look at it.
3.1.65.
3.1.65? Okay, very good. So can you just read it? Read it.
Farmer Ed has 400 meters of fencing and wants to enclose a rectangular plot that borders a river. If Farmer Ed does not fence the side along the river, find the length and width of the plot that will maximize the area. What is the largest area that can be enclosed? And they have
Very good.
x on both sides, and at the bottom it says 400 minus 2x.
Okay, so we'll get to that. So let's suppose we have a rectangular plot, and we have a total of 400 meters of fence. That's all we have, or fencing. That's all we have. We want to use it all and enclose the area so that this area is maximum. In order to use it all, I start at this point and I go all around till this point. You can say, how do you know? Not yet. I don't. It could be this. It could be this. I don't know which shape because I don't have the length and the width. All I know is that I want this area to be maximum. It could look like this, it could look like this, or like this. I don't know yet. So if I'm using the entire 400, then obviously x plus y plus x, 2x plus y will equal 400. Would you agree with this? At this point, we don't know what the length is. We don't know what the width is. We want to determine them in order to guarantee a maximum possible area. Say it again.
Is this when we have to solve for y, right?
Yes, I will solve for y, which is negative 2x plus 400. But then I have to create the area. So what is the area of this surface? Very good, x times y. But I need to replace y by what I just determined. So this is x, negative 2x plus 400. I will distribute negative 2x squared plus 400x. Now let's look at the problem with a different eye. Let's start from scratch. I'm given a rectangular area. I don't know the length and the width. I just constructed or determined the area of the surface or the plot, which is negative 2x squared plus 400x. So I want to determine x and y so that the area is maximum. Let's look at this function. What type of function is it? Excellent. Now my next question is, does it have a max or a min? Because if it doesn't have a max, then we're on the wrong track.
Yes.
It has a max. Why?
Because
Because the leading coefficient is negative. Good. Now the next question is, how do I find the maximum of such a function? Go back to your notes. We did a problem like this. What did we determine? There is only one answer, right? That's why the key is, in order to make progress fast, is to redo the problems we do in class several times till you are mastering them.
You gotta.
Yes?
Oh, we need to
Of course. Of course. There is no other point in the quadratic function that will give us max or min, but the vertex. Excellent. Good. How do I find the vertex? Excellent. Well done. Very good. Negative b over 2a. Negative 400 divided by 2a, which is negative 4. So how many meters should x be? Very good. This is the x. 100 meters. How much is y? I don't know. I have the relationship right here. I know x is 100. How much would y be? Excellent. And now I want the maximum area. I know the length is 200. I know the width is 100. I don't need to go back and plug it in. I already have the answer. And what is the answer for the maximum area? 200 and 2 zeros, right? Length times width. 20000. 20,000. Measurement unit, please. So max area is 20,000. What? Very good.
Wait, so the vertex, wouldn't the vertex be 100 and then the y value be 200?
No,
No.
it's a very good question. It is slightly confusing. The y is this piece. If it's confusing to you, I'm going to change this into w. And this is the y value of the vertex. So it's not confusing because we are really using the same letter. So I'm changing this into w, I'm changing this into w, and this into w. So there is no misunderstanding. The y indeed is the y coordinate of the vertex, and the length is w. So therefore, this must be the area. Or you plug back in 100, right? That's how we determine this. If you plug in 100, you will definitely get 20,000. How do I know? Because if the length is this and the width is this, that's how I got the area. Length times width. So it must be 20,000 square meters. Very good point. Excellent. Thank you. Yes, I used y, and we shouldn't because y is mainly reserved to the y coordinate or the function value. But this y is not the function value. This is the w, which is the width, which is the length, I'm sorry. Daniel, is this better? Very good. Next question, anyone? Yes?
The first step at back at the top, when you area lift times width. When you did x and then parentheses negative 2x plus 4, is that just to show that it's what is that called doing it that right there
This one?
next to it?
This one?
No,
This
X.
one?
Mhm.
I replaced w by this. I kept x, and I replaced w by what it equals to. I just
You just did x times with w. Okay.
Yeah, because the area is length times width.
Okay.
And I changed it because Ella had the point. I used the same value, like y, as the function value, and that's not okay to use the same. It may be confusing.
Okay, so you gotta know how to get the area, which is what time
Yes, you have, because that's what we're asked to do.
take out.
If I don't have a function that represents the area, then I will not be able to determine the maximum. Bless you. I have to have the function in order to determine its maximum. But thank you, Daniel, for bringing this up. It's a very good problem. Well done. Are we okay with this? Okay, so can anyone refresh our memory? What was that function? Or I can go back and find it.
It's f of x equals 3x squared minus x to the third.
Very good. So this is a polynomial function, and degree is?
Oh, it's 3.
Very good. Polynomial has degree as the highest monomial in there. We don't add exponents. We add exponents in a product. X squared, y cubed, z to the fourth. This is degree 4 plus 3 plus 2, which is 9. But in a polynomial, this is degree 2, this is degree 3. The highest degree transfers to everything. So this is degree 3. For any polynomial, the maximum possible number of terms, by terms we mean max min, is always the degree minus 1. So in this situation, when the degree is 3, how many terms does this function, can this function have at most? It doesn't have to turn at all. But yes, so 3 minus 1 is 2. Now let me come back to this graph for a moment. So let's look at this. We had this function x cubed a long time ago. We graphed it. What is the degree? 3. How many terms maximum can it have? How many does it? None. It never turns. Is always increasing. By turn we mean increasing, decreasing, decreasing, increasing. That's a turn, right? There are no turns here. This function is always increasing. Although the degree is 3, it can have at most 2 turns. It has none. So the point I'm making is maximum possible. It cannot exceed 2. It doesn't have to have any. Okay? But just remember, it cannot have more than 2. Okay. Then you're going to give me the domain. And now we're going to get the table started. So, domain. We shouldn't be thinking it's a polynomial function. There is no, right, negative infinity to infinity. Degree 3. How many x-intercepts do I have to find? Exactly. That implies 3 x-intercepts. I don't care. They may be the same. I don't care. I have to write 3. So let's find the x-intercepts. How do we find the x-intercepts for any function? Excellent. So 3x squared minus x cubed equals 0. Now, I think you know me a little bit. What do you think I'm going to do first right away now? So arrange it in descending order and multiply both sides by -1. Nothing irritates me, but I would say a negative leading coefficient is close. So x cubed minus 3x squared equals 0. I'm just trying to make you laugh so you can remember to get rid of the negative leading coefficient when you solve equations, not when you factor. When you factor out, but it's still there. But when I solve an equation, I can divide both sides by -1 or multiply both sides by -1. Then, of course, I will say this by factoring out x squared, and I'm waiting for you to give 3 solutions. We established from the beginning, degree is 3. It has to be, yes, anyone? Very good. X equals 0 and x equals 3. What is the multiplicity for 0 and what is the multiplicity for 3?
2 and 1.
2 for 0 and 1 for 3. Good. So let's put them in the table right now. 0 and 3. At the top, above x equals 3, because the multiplicity is 1, I will make myself a note. What note do I have to make?
Cross.
Very good. Awesome. Multiplicity is 2. What note do I make for myself? Very good. Awesome. You guys are awesome. We can write it, but there is no point in trying to find the y-intercept because when x is 0, y is 0. But let's write it. Y-intercept f of 0 is 0. Plug it in, 0, 0. Okay, now let's talk about what it's called end behavior. If the function is odd, we're not talking about symmetry here, and if the function is even. If the function is odd, there are two options. With a positive leading coefficient and a negative leading coefficient. Same two options. For even degree, let me write it. Odd degree, even degree. Because I don't want you to think of something else. Okay, so if the leading coefficient is positive and the degree is odd, it looks like the linear function. Odd degree will always be compared to the linear function, coming from negative infinity and going to positive infinity. That's a linear function with a positive slope. So it will start at negative infinity and go to positive infinity. What about if the leading coefficient is negative? Let's see. What will it do? From positive infinity to negative infinity. Very good. From positive infinity to negative infinity. What do you think, which function we will compare any even degree polynomial? Of course, to x squared. If the leading coefficient is positive, what will be the end behavior? From positive infinity to, right. I can't change that, right? What if the leading coefficient is negative? Yes, that's what the quadratic function does. So for a positive leading coefficient, from positive infinity back to positive infinity. For a negative leading coefficient, from negative infinity back to negative infinity. All even degree polynomial functions will behave this or this, in this way or this way. All odd degree polynomial functions will behave in this way or that way. So coming back, what is the degree for this? For this function? Degree 3. Can anyone identify the leading coefficient? -1. So it's odd degree with a negative leading coefficient. What will be the end behavior? From positive infinity to, that's it, from positive infinity to negative infinity.
How is the negative coefficient again?
Because we have negative x cubed plus 3x squared. I cannot multiply the function. I multiply the equation to solve. But the function no one can change. The function stays as is. Is that clear, Charisse?
Yeah, so.
Good. Yes?
And, okay, and just one more time, how do we get x is 0 again and x is 3? Because that's what it cannot go.
You mean the solutions?
Yeah.
X squared is x times x minus 3. When x is 0, x is 0. When x is 0, x is 0. When x minus 3 is 0, then x is 3. So this is x times x minus 3. This can be 0, this can be 0, or this can be 0.
Okay. Okay. All right. And then x can be 3 as long as it doesn't equal 0. So
It has to equal 0.
Oh.
We're not stating restrictions here. This is not a rational function. We are solving the equation y equals 0. Y equals 0. And we solve and we get x-intercepts.
and x equals 3, and it's only 1 because it only can go with the x minus 3.
Yes, because there is only one solution, x equals 3. You mean this one?
Yeah.
Yeah, because it appears once. X equals 0 appears twice. That's why multiplicity is 2. I have two solutions, x equals 0. But I have one solution, x equals 3.
Okay.
Is that better?
I kind of still don't really get it, but
So we established that this is degree 3.
right, because
I have to find 3 solutions,
okay.
3 x-intercepts. I have 3 factors, 1, 2, 3. Each factor will give me a solution. This factor will give me 0. This factor will give me 0. And this factor will give me 3. Okay, so let's look at the zero product principle. A times B times C equals 0. There are 3 options. Either A is 0, or B is 0, or C is 0. This was x, so I wrote x equals 0. This was x, so I wrote x equals 0. This was x minus 3, so I wrote x equals 3. So we got 2 solutions, 0, multiplicity 2. The function will turn there. We got 1 solution, x equals 3. It will have to cross. Better?
Yeah, somewhat.
Okay. Good. So where are we here? The max min, if you remember the list. Should I write the list one more time with all the requirements? Yes, I'm sorry, Rachel, you did raise your hand. I forgot.
I just have a question.
Yes.
The odd degree, why did it start out? Why did you say it started at the positive went to the negative with the leading coefficient of negative?
Very good. Very good. So any odd degree polynomial function behaves like the linear function when it comes to the end behavior. Nothing else, just the end behavior. This is a linear function with a positive slope, coming from negative going to positive infinity. This is a linear function with a negative slope, coming from positive infinity and going to negative. And this function is odd. It has a negative leading coefficient. It has to start at positive infinity, and it has to go to negative infinity. For 2 reasons: odd degree and the negative leading coefficient. Better? Good. Other questions here? Other questions?
So then if the leading coefficient was positive,
If the leading coefficient were positive, yes. It will have started normally at negative infinity and go into positive, increasing.
okay.
But if the leading coefficient is negative, it will be, you can think in terms of decreasing
Okay.
from left to right. But for these two, this is special. It's either infinity, infinity, or negative, negative. And you always think of the quadratic function. Quadratic function x squared with the positive leading coefficient is this. Degree 4, degree 6, degree 8, degree 10 will look like this if it has a leading coefficient that is positive. How do I graph negative x squared? Because the leading coefficient is negative. Any degree that is even, 4, 6, 8, 10, if it has a negative leading coefficient, will come from negative infinity and eventually go back to negative infinity. I always compare to either the linear or the quadratic because I don't want you to memorize this. What's the point? Good. So let me list the requirements for all these polynomials one more time. So to graph a polynomial function, and I will list it on the test and final exam. They will be listed, but let's list them one more time. To graph a polynomial function, steps to follow. 1, The order is not important. So I'm going to list all of them, but you don't have to do them in this order. As you know, the first problem will always take like, it seems like forever. The second one will take us 3 minutes. All we have to do is just fill up that chart. So 1, domain. 2, X and Y intercepts. 3, multiplicities of X-intercepts. Why? Because I know what happens. It either crosses in a certain way or turns in a different way, and so on and so forth. 4, degree. This could be up there with the domain. 5, max possible number of turns. By turns, we mean max min. It cannot have more. It doesn't have to have that number, but it cannot have more. 6, max and min values and where they occur. But we cannot do this by hand, not in algebra, right? So I'm going to write in parentheses TI-84 or 83 or whatever you have. Number 7, end behavior. Number 8, symmetry. It's nice to know whether a function is symmetric or not. They may or may not be. So this is pretty much everything we have to cover for polynomial functions, degree 2, degree 3, 4, 5, and so on and so forth. So coming back to our table, I have everything. I have the domain. I have the X and Y intercepts. I have the multiplicities. I determined them, and I've made myself the corresponding notes. The degree I know the maximum possible number of turns. I did not determine this just yet. I can't, not just yet. I have the end behavior. This is the end behavior, negative leading coefficient and odd function, odd degree. And the only thing that I'm missing is the symmetry. Well, a function that turns at 0 and crosses at 3 will not be symmetric, but I do have to write what we wrote a long time ago in chapter 2, f of negative x, which is, remember we replace x by negative x. So we have negative x to the third plus 3 negative x squared. Let me refresh your memory about the symmetry. Functions have 2 types. When f of negative x equals and when f of negative x equals something else. Do you remember the first one or the second one? It doesn't matter which one you want to start with. I know it was a long time ago. F of negative x equals f of x. What type of function is that? Always remember this. Negative x, positive x, positive x, negative x. What am I trying to do with this function? Reflect with respect to the y-axis, so it's even. And the other option is negative f of x. Let me refresh your memory on or beg you again. Every weekend, you must redo your tests. Every weekend, till the end of the semester. If you don't, we're going to start from scratch when we start reviewing for the final. And that's not beneficial at all. Where our head will explode. We're not going to know what to review first. So you must make yourself a note in your calendars or any Saturday, Sunday, redo your first test. Once on Saturday, you have solutions, you have everything. Once on Saturday and once on Sunday. Every weekend, please. Okay, and this is odd. But in any event, we have to determine f of negative x. I don't know if it's even or odd before I calculate or determine f of negative x. So negative x to the third will be negative x to the third, but with minus in front will be positive x to the third. And negative x squared is x squared with 3 in front is positive 3x squared. Well, it turns out that this is not the same with the function, and it's not negative the function. So not symmetric. So finally, let's graph this function after all this talk. Okay. I only care for this. I will never look at anything else. This is all I need. You can say there's too few points in there. I would say yes, I agree. You can find any ordered pairs you want. You can plug in -2 and find a number for y. Plug in -1 and find a number for y. Plug in 1 and find a number for y. Plug in 2 and find a number for y. Now plug in 4 and find. There is no need. I don't want you to spend too much time on this. Let me show you why. Which page am I on? Is the 4 that is 5 or the 5 that is 4? Or whatever. Okay, I just put 5 in there. So when I graph these functions, first I start with what I have. I have 0, 0, and 1, 2, 3, 0. That's all I have for now. So let's read this together and graph it. The function is coming from positive infinity, and it turns at the origin. Okay, that's not a problem. It's coming from positive infinity, and it turns at the origin. That's what I have, coming from positive infinity and turning at the origin. Then it has to cross at 3, 0. Well, it has to come to a maximum somewhere in order to cross normally at 3, 0 and go to negative infinity. That's the reason why I suggest do not work too hard. We really do not need too many points for this. So let's do this one more time together. It's coming from positive infinity. Yes, it is. It's coming down to the origin where it's turning. That's my note. Two solutions here. It must be turning. And then somehow it has to turn because it's coming down to cross at 3, 0 and eventually going towards negative infinity. And now you can say, yeah, but you don't know how big this is. I don't. And we don't have tools in this class to determine that except with a graphing calculator. But I will be able to determine this in a minute. Okay? Always write the function. What you graphed is -x³ plus 3x squared. So you know what it is. And now let's punch it in the graphing calculator and see what happens. So in y equals, clear if you have anything else. So this was -x to the third, and then plus 3x squared. We already graphed the function. Yeah, I have a cheat sheet here, as you see. -x to the third plus 3x squared. What is that? It doesn't. Yeah. Okay. So zoom 6. Just behave. Ah. How is it possible? I don't know what it's doing. Don't even worry about it. Just look at the function that we have, right? It's coming from, I don't know what that, oh, it changed now. Okay, it was a delay. Okay, so coming from positive infinity, it's turning at 0, 0. It's coming to a maximum. It crosses at 3, 0, going to negative infinity. That's exactly what we expected. Any questions before we determine the maximum? I thought I punched it in incorrectly because I was getting a different graph. I said, what is that? Okay, so here's how we determine the maximum. Are we okay? Did we all get this graph? Yes? Okay, so let's determine the maximum. We see that the maximum is between x equals 0 and x equals 3. The calculator will ask us where to look for the maximum. So let's do this. Second and calc. Second and calc. Which do you think I'm going to pick? 4. Very good. It's asking me to give me a left bound. I will give the left bound to be 0. It's asking me now, give me a right bound. I'm going to give the right bound as being 3. See, the calculator is telling us, or I tell the calculator that this is where I'm looking for the maximum. So now, I don't want to guess. Just give me the number. Press enter again, and we get the maximum as, I'm going to round it up to 2, 4. And I will go back and put it in my table. 2, 4, local max.
Wait, let's see.
Yes, let's take a look. So in y equals,
Oh,
in y equals, we will have negative x to the third plus 3x squared. And then you go to zoom and press 6 because we want standard. We can change the viewing window if we want to. Any questions? So I will put in the table and I'm done. Any questions for me, please?
you said second calc, right?
Second calc, yes, for finding the maximum.
That's what I was asking you where calc was on here.
Oh, I'm sorry, I thought you didn't have the function in. So it's right here, but you have to have the function
Oh, right
first.
there.
Right, so second and calc, and you give it 0, enter, 3, enter, and press no guess. Oh, it did something else. Oh, you picked 0, I picked 0, so we want maximum. Okay, from 0 to 3, and you get that. 2, 4. So this was an odd degree. Any questions? Let's choose an even degree. You know it's not going to be different. What is going to be different? Just the end behavior. Nothing else will be different. It will either be this or this. Same thing. So let's pick an even degree. We're on page 378. Can I pick one? Very good. I will pick 62. 62 is f of x negative 3x cubed in parentheses x minus 1 squared in parentheses x plus 3. Domain, please.
So the f of x is the y value.
F of x is the y value. Yes, f of x or y, you can even write it here. It's the same thing. Yes, y or f of x. You know, you can say, okay, fine. So why do I need 2 different notations for the same thing? First of all, x comma y is a point. I'm not saying that it's wrong to write x comma f of x, but I may not have a function there. So that's why I need x comma y as a point without a function, right? Now, a point on a function is x comma f of x. So that's why we need to use both. When we have a function, we use f of x. When we don't have a function, I still have to have the y coordinate of the point. So we need both. Domain, please. Good. Degree, please. This is 3. This is 2. I have to square, right? X squared is not 1, right? And this is 1. So this is 3. This is 2. This is 1. 6. How many X-intercepts? I'm going to write it so I don't forget. Indeed. 6 X-intercepts. Max possible number of turns. Maximum 5. It doesn't have to have 5, but it cannot have more than 5. Very good. Degree minus 1. That's the law. Yep. Very good. So now the x-intercepts. -3, x cubed, x minus 1 squared, x plus 3 equals 0. 1, 2, 3, 4, 5, 6. Okay, which one? X equals 1. How many times?
1.
Very good. Twice. Multiplicity 2. Perfect. Say it again. -3. How many times? Multiplicity 1. How many times? Very good. X equals 0. Multiplicity 3. Is this 2 plus 1 plus 3 the same with a degree? It has to be. Correct. So let's put them in the table. -3, 0, and 1. 0, 0, 0. What will you indicate above -3? A cross. What will be the note above 0?
Turn.
Yes, so it's a cross but flat. All odd multiplicities are cross. Flat. A flat type of cross. Okay, what about 1, 0? Multiplicity 2. No multiplicity 2 crosses. Yes. It turns. Very good. And behavior. And I'm done.
Wait, how are you getting the f of x to be 0? What is that?
In order to find
in
the
your chart. Whereas -3.
so 1, 0, -3, 0, and 0, 0. Was that the question?
Yeah, I just.
So
you can keep. I'll get it out.
no. Wait a second. So we are trying to find the x-intercepts. So when I try to find the x-intercepts, I have to set y equal to 0. And this is y. Set equal to 0. Right? This is what we did. This is what we did here. We set the function equal to 0, and we determined x equals 0 twice, and x equals 3 once. So this is the same situation with a different function. You will divide both sides by -3. -3 has nothing to do with anything. So x cubed equals 0 gives us 3 solutions.
Well, I understand that.
Oh,
It's
I'm
okay,
sorry.
It's okay. I get it. It's okay.
You can still finish for me. I don't mind.
So 3 zeros from here, 2 1s from here, and 1 -3 from here. So the question is how we get the zeros here underneath?
Yeah.
Why 0? This is y. This is y. Y is 0. When I set y equal to 0, I get -3, 0, and 1. This is y equals 0. So I get x equals 1, x equals -3, and x equals 0. I have to have 0 here.
So it's always going to be 0 since you have to.
Because the x-intercepts are determined when y is 0, right? So that's what we did on the previous problem, right? So when we determined 0 and 3, we had to write 0 for the y value. Because these will not be x-intercepts unless the y value is 0. So when the y is 0, then I determine x equals 0 and x equals 3. Is that better?
Sure. Yeah, that's good.
And on the problem that we're working on,
So we have this function. Don't forget what you want to ask, because sometimes so please don't forget. So we have this function and we want to determine the x-intercepts. We have to set the function equal to 0. So whatever I get, the y will be 0. So that's how I got x equals 0 and x equals 3, by making y 0. I made y equals 0, and I determined these two solutions. So when I put them in the table, 0 and 3, I have to write 0 under for the y value. Like we did, do you remember the quadratic function that we worked on a few minutes ago? We got x equals 1 and x equals 3, comma, y equals 0. Why did we put y equals 0? Because that's how we determined 1 and 3. Exactly the same way here. So we set this function equal to 0, and that's how we got these two numbers. Therefore, y must be 0 at those points. Because these are the x-intercepts, 0, 0, 3, 0. Like when we got 1, 0, and 3, 0. So now, is that better now? So now, when we set y equal to 0 and we get these three numbers, then y must be 0. Because they are all x-intercepts. They must be on the x-axis. -3, 0, 0, 0, 1, 0. Better? Okay. So now we have a degree which is 6, which means I have to compare to either x squared or negative x squared. The degree is 6. It's an even degree, right? So what is the leading coefficient? So is it going to be from exactly? Is that clear? Okay. So it's going to be from negative infinity to negative infinity.
So
And
the
yes?
the points at the bottom for y